Hi guys, welcome back to the channel, and today we'll be talking about problems 4, 5 and 6 from the National Selection Test model paper. So we have a sample 2 paper, and now we're just going to be continuing our discussion. So let's look at problem 4 first. Maybe I can try and imitate a British accent. Given a quadrilateral ABCD with AB equals to BC equals to CD, angle ABC is equal to 90 degrees and angle BCD equals to 60 degrees. Find angle ADC in degrees. Oh my god, I don't know what kind of imitation was it. Maybe if you think that it was not bad, you can write it in the comments. No, I'm just asking for some interaction now, okay? So now back to the question. So we have AB, BC and CD. So maybe I should draw this first. So this is our AB, BC. Then we have these two of the same length. And then for CD, this one is also okay, so these two are also of the same length. So now, what I like to do is I would like to draw an auxiliary line. Auxiliary lines are actually very important in mathematics Olympiad questions because they help us a lot with dealing with geometry problems. So the auxiliary line I'm going to draw is along BD. So we can look at the triangle BCD. So triangle BCD is isosceles. I'll just write the short form. Why? Because we see that BC equals to CD and then this is 60 degrees. So this means that angle CBD and angle CDB are of the same value. So we will have angle CBD is equal to 180 minus 60 divided by 2 is actually 60. So this is 60 and this is also 60. So now what happens is that BD is actually also equal to AB, BC, CD. So this is an equilateral triangle. So now we would like to find angle ADC in degrees. We know quite a large part of it is 60 degrees. Now we know that this is 90 minus 60 is 30, angle ABD. And then we know that this triangle ABD is also an not equilateral but isosceles because AB is equal to BD. So these two will be of the same length. So the measure for angle ADB would be 180 minus 30 degrees divided by 2 is equal to 75 degrees. And now if you want to find angle ADC is equal to 60 degrees from angle BDC, and then plus a 75 degrees from angle ADB is equal to 135 degrees. So I'll just jot it down right over here and I'll erase it for a while and you guys can look at problem 5. Now, looking on to problem 5, so I'll just read the question. A math club has 7 members. The club advisor wanted to choose at least 4 members to represent the club in the math contest. How many ways are there to do so? So here I'll be presenting 2 ways of solving this problem. So the first one will involve permutation and combination. And if you guys who would like to use this way of thinking are not really very familiar with the topic yet, maybe you can search on YouTube. There's a whole lot of videos explaining this. And the second way is to maybe from a different standpoint, so different point of view, and then I'll just explain why. Okay, so using permutation and combination, the club advisor wanted to choose at least 4 members to represent the club. So he could choose 4, he could choose 5, he could choose 6, he could choose 7. So using this very classic combination way, what we'll do is we'll write 7C4 or maybe 7C4, I don't know, something like this, plus 7C5 but 7C6 plus 7C7. If you think this is a actually very strange bunch of numbers, do not fret because I'll use another way of thinking later. Okay, so this one you just use the formula. Okay, NCR is equal to n factorial. Factorial means 1 times 2 times all the way up to n. Okay, divided by r factorial and then divided by n minus r factorial. So I'll just write down the numbers. I won't use this formula. So 7C4 is actually equal to 35 plus how do I say, 7C5 would be 21, 7C6 will be 7 and 7C7 will be 1. So adding all these up gives us 64 But I won't end here because there is actually another more interesting way of thinking. So I'll erase this first. So what do you think is my way of thinking? Because it's actually, I don't know if you guys find it interesting, but I do, because it involves some kinds of observations. Why, for example, like why did they choose 7? Why do we need at least 4? Why couldn't we just write, oh, exactly 4 members? Right? Because why don't we just say exactly 4? Because actually the problem won't be so interesting. So think of it this way, okay? So this club advisor, he could choose 0, 1, 2, 3, 4, 5, 6, 7, right? So he could choose any number from 0 to 7 number of members to participate in this math contest. But look at 4 and 3. So 4 and 3 means like 4 plus 3 is 7, right? So if we add like this, so we can see maybe 2 and 5, and then 1 and 6, and then 0 and 7. So think of it this way. So my different point of view is that if we are to choose 3 people, it is actually equivalent to me not choosing 4 people. And if we were to choose 4 people, it means not choosing 3 people to represent in that contest. So maybe I should write out, if I say I choose 3 people, is equals to I'm not choosing 4 people to represent in the contest. So this is actually a very special way of thinking. And now, okay, now for the another fun part. So how many ways are there in total if we want to add all of this together? So if you know the combinatorics one, so maybe say, oh, 7C0 plus 7C1 add up all to 7C7 is equal to 2 to the power of 7. Why? Why though? Okay, so in choosing, we do not care about the order, right? So what we have is for maybe we can say the members are A, B, C, D, E, F, G. So maybe say A, B, dot, dot, dot until G. So for A, how many choices do I have with him? Maybe I can choose him, or either I do not choose him. So I have 2. Ditto for B, C, D, all the way up to G. So I might either choose A or not choose A, either choose B or not choose B, all the way to G. So 2 times 2 times 2, we multiply itself by 7 times, so we get our 2 to the power of 7 is equal to 1 to 8. Okay, but now say we have this second half. Okay, so we have 4, we need to choose 4 people is equal to not choosing 3 people to stay. Maybe say choose 3 people to stay, don't say not choosing, in order to avoid confusion. And then we can say, oh, I can choose 5 people is actually equal to me not choosing 2 people to, or should I say me choosing 2 people to stay, not go to the contest. And then if I say I choose 6 people to go to the contest, it means me choosing 1 person to stay, not to go to the contest. And then to 7 means, yeah, I just let everyone go. Okay, so since this one and this one are the same, so 1 to 8 is so the answer to this is actually 1 to 8 divided by 2, because we know choosing 3 people and choosing 4 people, the number of methods are the same. 2 and 5 same, 1 and 6 same, 0 and 7 same. So 1 to 8 divided by 2 is 64. Okay, so this one is actually a longer way of explanation, but I hope you understand it, because these two are actually very interesting ways of thinking. Now let's move on to problem 6. Now problem 6, in a fruit shop, oranges are not sold individually. They're sold either in small packs, 3 oranges, or in large packs, 10 oranges. For example, it's possible to buy exactly 13 oranges, 1 small, 1 large, or 5 oranges, 15 oranges, 5 small packs, but it's not possible to buy exactly 14 oranges. So what is the maximum number of oranges that cannot be bought exactly? Okay, so I don't know about my imitation. Maybe I can just try imitation every question. But now, we need to, this is a very, how should I say, hard problem, because for me, I need to write out every number, not write out every number. Okay, so let's list out. So I'll use from the standpoint of 3, and then I'll be using modular arithmetic. So using mod. If you do not know, maybe I have did a video before, but it's in Chinese. If you know Chinese, can look at that. So I'll be using mod 3, and then I'll be using the remainders, or if it's remainder 0, remainder 1, or remainder 2. Okay, so if it's remainder 0, it means that it's a multiple of 3. So for every multiple of 3, I can buy that number of packages, right? So I can buy maybe say 3 oranges, 6 oranges, 9 oranges, blah blah blah, and so on. And then for 10, so 10 10 itself is 1 mod 3. So starting from 10, I can buy 10 oranges, and then plus 3, it will be 13 oranges, 16, 19, and so on and so forth. And then 10 times 2 is 20, so this one will be divided by 3, we have remainder 2. So we'll start from 20, and then just add on 3, and then 26, 29, and so on and so forth. So after a certain number, you can buy any number of oranges here. So okay, let's look at the whole, how should I say, the whole number line, I should say. So we know 18 is a multiple of 3, and then 19 we listed just here, and then 20, 21, 22. Now all of these numbers we can buy. What about 17? 17 is actually the largest number we can buy over here. I don't know if I'm really explaining this problem in a very proper way, but I hope you guys can observe this, because this one might take a lot of time. And regarding this problem, there's a theorem on number theory. I'll just write over here. If you're interested, you can search it. So it's the chicken McNugget theorem. Okay, it's a very strange name, right? I also think so. So there's this trend that maybe people go to McDonald's drive-thrus, and then they ask for a certain number of chicken nuggets, and then for the staff, they cannot give out the exact number because they do not sell in packs of those, so hence the name. So if you're interested, you can go and check out. And today I'll just stop here. If you think my problem 6 I didn't explain very well, you can write to me in the comments. I'll explain further under your comment. Okay, so that's all for today. Ciao, adios, ciao.